Welcome to Space Center Houston, our virtual science symposium. Today we have with us David Overland and Candy Torres. They're from Creator Space. Welcome, guys.
Thank you.
Thank you. Creator Space is the local makerspace in the Clear Lake, NASA area. We've been around about 3 years, and we were asked to put this together because we do things like 3D printing and robots and things. So I worked, just recently retired from NASA after 25 years, also of which 10 years I spent trying to figure out how to live on Mars. So this is kind of fun for me. Candy?
I'm Candy Torres, and I worked in the space industry on a satellite project at Princeton University Astrophysics Department. Then I came down here to work on the space shuttle, doing software development for the flight controllers and mission control. And then eventually I moved into working on the International Space Station, where I did backroom support. And I've been with Creator Space for a couple of years now, and I love 3D printing and I love technology.
So we've been asked to talk about 3D printing and 3D modeling in preparation for the Mars base thing that you guys are doing. So can you bring up the charts, or are they there already? Yep. Okay. So what we're going to talk about today is what 3D printing is, and what is 3D modeling, and what are the differences between those two. We're going to do an introduction to Tinkercad, which is a web-based 3D modeling program, and then the main tool that we're going to be talking about is SketchUp, which was originally invented by Google. So we're going to talk about how to install it, what the basic tools are, and then we're going to actually use SketchUp to model a dome for a Mars base. So then we'll take any kind of questions you have. So 3D printing is kind of like regular printing, where you're laying ink on a piece of paper, but instead you're laying pieces of plastic or some sort of solid material in multiple layers until you build up a 3D model. And I brought a few things here. That's a little robot, an octopus nut and bolt, which you can do some fairly fine details with these things. You can make hollow things. You can make sculptures out of it. And most of the printers that you will see that aren't expensive, $100,000 machines, will use a melted plastic filament. So they'll basically feed in the filament and then melt it and basically paint each layer of your model in plastic. There are other types of printers. Other types use powder, where you basically use some sort of binding agent and do one layer at a time with the powder. And you can do some fairly exotic powder. You can actually use powdered metal and lasers and actually print something out of metal. Recently, NASA, I think, printed a part of a rocket engine with a metal 3D printer. Another technology that's used is just using paper, where you basically print out each piece of paper and cut each layer out, and then stack all the pieces of paper on top. You've got a 3D model. You get some fairly fine detail that way. The newer printers are going to be using resin-based, which is sort of a liquid plastic, and using a laser or some very bright light to basically paint each layer, or use basically an LCD screen, like your monitor, with the backs and everything, so it's clear. Put it down there. You can flash each layer one at a time, and that goes really fast. 3D printing is not a very fast process, but that would actually speed it up quite a bit. And expect those to, some of the patents have expired, so those will be in the open source market the next year. The other half of 3D printing is, if you're going to 3D print something, you need a 3D model. Just like when you go to print a picture on a piece of paper, you need a 2D picture. The file types that are mostly used are called STL files. So almost all 3D modeling programs or 3D software will be able to export an STL file, which is stereolithography. Or they'll be able to output something that can be converted to an STL file. An STL file is basically what you used to see as the wireframes, bunches of triangles and polygons. That's what they are. So all the other information is lost when you print. There's a lot of 3D modeling software available. There's a lot of commercial systems, there's a lot of free, and then there's what we call open source, where you actually have access to the source code and can make modifications yourself. Different types of software that can be used for this are the big CAD/CAM, computer-aided design, computer-aided manufacturing, Those are probably the kind that you're going to learn how to use in school. Types of those are something like Autodesk 123D or Autodesk Inventor, which are spin-offs from the old AutoCAD programs. There's an open source version of that called FreeCAD. One of the best free versions that we've run across at CreatorSpace is called Design Spark Mechanical, and it's a fully functional, professional quality CAD system that also exports, and they put it out there for free because they're selling parts that you can design with. Animation software, 3D animation software like Maya or Blender will also be able to do this kind of modeling. And then you've got regular modeling software where you're drawing things in 3D. And there's 3 different kinds of those. There's creating things out of polygons, which is pretty much what SketchUp does, which we'll be talking about in Tinkercad. Or there's other ones that are more sculpting, where you end up with a sort of a sphere of clay and use your mouse to push and pull it into different shapes. And then there's parametric ones, where you can actually sort of code your object into it. So you can like build a little gear script and tell it how many gears and how big it's going to be, and it will automatically generate those for you. And one of the ones that I use is called OpenSCAD. And it's more of a programming your object than drawing it. So there's lots of different ways to do this, all of which will get you to where you want to be. So we're going to be talking about SketchUp, but if you're familiar with or comfortable with another tool, go ahead and use that, because yeah, it's always easier to use what you know. Candy is going to do a quick 5-minute introduction to Tinkercad, which is one of the easiest entry-level modeling tools that we've run across. Let me bring up the video. Okay. Candy?
This is my very quick and dirty video, and here's what the page looks like, and you can sign in. It's free, and then you can get your gallery or dashboard there. Here's some of the basic tools that you'll use. Obviously, create a new one, duplicate what you've got on there, save. We'll get into properties in a moment very quickly, and then of course the close. And then the next one that we go to is going to be editing, and pretty standard with your copy and paste and duplicate. And when you get something, you'll have more of those highlighted up there. This is what the basic screen looks like, and if we want to design, in this case I want to rename it because it gives you a jumble name, and then I put in dome construction, and then I would hit the save changes down below on the blue. It's a little jumpy on the movie. All right, what we have on the right are geometrics that exist, and you click on one and you drag it over, and then you have little squares that you can use to resize it. And when you get it the size that you want, and again you can change it later, you want to look at the view. And so the tools on the left, a little round, it gives you different ways of orienting the material, so you can decide where you want it. In this case I also wanted to duplicate, so now it's going to, I shrunk it down because I want to make walls to my dome, and you can see there's a gray area. It makes it into a hole. So now there's a hole, you can see it, you're going to drag it over inside, but you know, it's a little hard to get it just right, and I didn't quite make it. So there's a tool on the upper part. First you have to select all of it, and then go to adjust and select align, and these little bars and dots, and you click on the appropriate ones to make sure you align the hole with the dome. And now we're going to verify that with the tool on the left, and you can see it's rotating the plane, and now you see that this gray area here is your hole. So you've got, very quickly have made a dome, but we want to get inside of it, so I selected this little round roof, they call it, and I'm going to drag it over and roughly put it where I want it, and we're going to stretch it a little bit. You also want to make sure that it's inside enough, and I duplicated it, and now I'm going to change that size and just roughen it out because I'm not trying to get exact at this point. And it looks like we're going to do that, and then we're going to make it a hole. So same thing we did before. So now it's a hole. I'm going to take it and move it over to where the door, we want the door to be, And it looks like I might have it exactly right, but I'm not sure. So I have to select both of them and not select the dome itself. And then there's the align tool again. And just to verify, go to the left, and I'm going underneath, and I can move those pieces down to make sure that the hole really did go all the way through. Not fine tuning anything there, it looks pretty good. So I've got my little igloo. And then you would just do design, save, and there it is on my dashboard. And here I'm going to rotate it, and it looks a little bit more realistic because you don't have that gray area that indicates a hole. You actually see it as a hole. And then there's a little gear up on just above it, and that has a few little action items you can take outside this. You can do the properties. You can duplicate this project, move to another project, or delete it. And then you've also on the left, you see Tinker This. If you clicked on that, you'd be able to reopen your project. And that's it.
Mm-hmm. Thank you, Candy.
I think we did have a quick question.
Sure, yeah.
We have a question. What is the cost benefit of using 3D printers for the aerospace industry? I'm sorry.
The 3D printing is mostly, it's not really a production type of thing because it does take a long time, but it's good for basically doing prototyping or working out different design trades where you can actually hold it and run some tests on it. A lot of times you can see things in a drawing, but holding it in your hand and actually seeing how things fit together makes a world of difference when you're doing design. For space, though, one of the reasons NASA has been looking at it for a number of years is that we have to bring everything with us when we go to space. So that means every spare part you possibly could use, or we have to ship it up there at like $20 million a pound. So if you could make the part you needed, all you'd have to send up was a file, which weighs nothing. So, and then you could make the materials in space. So there's been a lot of work over the past few years to try to figure out how to do that in zero gravity, or how to do that on the surface of the moon, or how to do that on Mars. So that's one of the big benefits of being able to do things as needed. Sometimes you don't know what you need until you need it. So
And I have another question.
Sure.
Sorry, I've lost it. What material supports a home 3D printer?
The two main materials that are used for 3D printing are PLA, which is a hard plastic that's actually derived from corn, and ABS, which is the plastic they make Legos out of, so it's also very durable.
Okay. The materials used in a 3D printer are strong enough for the Martian conditions?
If you were basically building something on Mars, depending on what you needed, yes, the plastics are plenty strong enough for, if you've ever stepped on a Lego, you know how hard they are. But for the metal ones, there's a titanium printer that was developed, I think, out of Goddard, which they've been looking at, which has been space qualified. It will work upside down. It can plug into the space station power supply, for instance. And it uses an electron gun as to melt the titanium wire to build the things. And yes, it would be quite strong enough. Though the rocket engine nozzle part was, I think, a sintered aerospace alloy. I don't really know what the alloy was. So yeah, it can be quite strong.
Okay. Which 3D printer system do you think is the most useful for our project?
Whatever one you have access to. I have a MakerBot Thing-O-Matic, which is about 3 or 4 years old. So that's what got me into 3D modeling. We've been working very closely with the Harris County Library in the NASA area, and they've got a MakerBot Replicator 2, which is about this big, and can do a piece about this big. And they also have what's known as a Gigabot, which was designed and developed in the Clear Lake area, which can do a 2 foot by 2 foot by 2 foot build. It can literally print for days. You can print a chair with it. Whatever 3D print you have access to will be more than good enough for what you're trying to do, I think. Okay. So where was I? SketchUp is what we're going to talk about today. When we were asked to do this, we had to think about what kind of software to teach. Tinkercad is what the library is using because it's a really nice entry-level modeling tool, and you can do some pretty decent things with it. We eventually settled on SketchUp, which, because there's been around for a few years. It's free also, and there's 100,000 YouTube videos and instructions on that. So it's got a really big support base. It was originally developed by Google, and a lot of people still call it Google SketchUp, but Google rolled it over to a company called Trimble, so it's technically Trimble SketchUp. If you've ever heard of Google Earth, it's sort of like Google Maps in 3D, where you can fly around the Earth and fly into buildings and fly down through streets and things like that. So rather than Google modeling everything in creation, they developed this tool for you to or people to model their own buildings. Or their own monuments or that sort of thing. So a lot of the buildings at Johnson Space Center, for instance, were modeled by somebody. And so it also has a nice geolocation kind of thing. So you can give it the longitude, latitude, or the GPS coordinates, and we'll put it in Google Earth. So you could literally design your room and put it on your street in your house, and then use Google Earth and go into your room with all the furnishings and everything else. So it does houses and buildings very well. And what I was told you guys were doing is a base, a habitation kind of thing. So houses and buildings. It's free for personal and educational use. There's a professional version now that Trimble has it, which costs a few $100s. So unless you've got a lot of money burning a hole in your pocket, you could probably spend it on something else. The other nice thing about Google SketchUp is that there's a 3D warehouse included, because it was originally designed to share models. And in fact, there have been several competitions like this. You can look at what other people have done as far as designing Mars base or Mars habitations. And we'll step through a little bit of that towards the end. Want to talk a little bit about how to get Google SketchUp. It's from sketchup.com. And I put two charts together that told you what you need to fill in. I'm going to go to it, and this is what the homepage looks like. Click on download. There's two different versions you have to pick. So you are educational. So, and then it asks you questions about what you want to do. So there's drop-down menus. You're a student. You pick your operating system. And over here you pick your product. So SketchUp Make is the free version. SketchUp Pro is the one that costs about $500. And then so you go through all of that, and it will eventually take you to a download page. It will ask you for a license agreement. It will ask you if you want to be on the mailing list. You can check or not check as you want. It will also ask you what school you go to and whether you want Windows or Mac. And it, again, asks you that at the very end. So these are some of the things I'm going to try to emphasize as we go through building a model. Because these are the things that aren't always clear when you're looking at the tutorials and the videos and people are just stepping through building things. But how do you specify how big something is going to be? And these are things that are not actually all that easy to do in SketchUp until you figure it out. Guidelines are basically pseudo-visible lines that aren't part of your model, but you can specify where they are very, very accurately. So and when you move things around, you can get them to lock into the guidelines. If you want to put something precisely, you pretty much have to figure out how to use guidelines. You use the arrow keys to figure out whether you want the X, Y, or Z axis. If you're moving something, or what are the three things here? It uses for making lines, for moving things, and for also using the tape measure tool. So, and that's very, very important because you'll see as we get into Google SketchUp, Google SketchUp tries to infer what plane you're trying to draw something on. And that can get very, very confusing. It looks like it's in the right place until you turn sideways, and then it's like 10 feet off. So guidelines and arrow keys are going to be kind of important there. I've got component and explode for 3D objects. If you're trying to design a solid thing, like Candy was doing with the dome, in order to do intersections and do holes, you have to actually make it a solid. So that's when they call it components. And when you finish doing that, you have to explode them back into the different pieces. SketchUp uses lines, planes, and components. So those are the two things that or the three things that it does. Two other things that are going to be kind of important to know about are using the instructor window, which when you use one of the tools tells you everything you can do with it and tells you how to use it. And it's kind of in the way if you know what you're doing, but it's really kind of invaluable if you don't, especially if you're using that tool for the first time. And then you can't natively export the STL files with Google, with SketchUp, but they have a plugin warehouse which allows you to add that capability, as well as a lot of other capabilities that are available to it. So when you get finished and want to output a model, you're going to have that installed. And it requires a Google account, Gmail or Google Plus or whatever that. So next one. These are the tool sets, and we'll be stepping through all of these when we step into the tool. Very, very similar. There's a bunch of little icons. Selection, eraser, draw, arc, and I'll be stepping through each one of these individually when we step to it. And you have a lot of choices of different tool sets, and I'll show you how to open and close those as well. And then the regular, and some of them, if you might notice where the pencil is, there's a little down arrow, and that the drop down, so you have choices about what you want to do, what kind of shape you do. And it remembers the last thing you did, so if it's the next thing you want to do, this shows how to get to instructor. And I assume these charts are going to go forward to the people. I assume that's why we made charts. Okay, so you can look that stuff afterwards, and then I'll be going through a number of resources. So let's get out of here for now, and then let's bring up Google SketchUp. So I've got it on my desktop with a bunch of other things, and this is what happens when it opens up. You have choices of what kind of template to use. You can do feet and inches, you can do meters, you can do architectural designs. There's one down at the bottom for actually doing 3D printing in inches or millimeters. It doesn't really matter. You can do this in full size, with meters and feet, and then you can shrink it down later on to print. So I've got it set up for just meters, because meters. One of the things I found was doing feet or inches, when you just type a number for a dimension, it automatically assumes it's inches. So you actually have to put the single apostrophe and the double apostrophe in it in order to get feet and inches. In meters, you don't have to do that. So start using SketchUp. It's down here at the bottom, and then it takes a second and it opens up. I've got the large extended tool set on the side, and it will remember the last thing you did, so I don't at this point know what it comes up with automatically. We've got different views over here and then some solid things over here. So File, New Open, Save As, and down here, this is where I've Export STL, which I've added to it. Edit, redo, cut and paste, all those kinds of things. Select all, and you select the little person there that lets you know how big 6 foot or 5 foot is. View, you can move things around. You can show hidden geometry, which is really good when we're going to be doing domes. Section cut, axis guides. You can do some lighting and coloring and things like that, which we're not going to be doing. So there's where your model is, and then the camera is what you're looking at, is what they call that. So you can move your view of things around. And rather than use, okay, let's go back to camera. Orbit, pan, and zoom are the main ones that you will use pretty much constantly. Orbit is to be able to spin around the object, and I will show, and you do that from the mouse by using the middle button, the wheel, and you can grab it and you can swing it around like that, up and down, back and forth, you look underneath like that. Pan is, and there are icons for that over here. So that's the move around, and where you can do that also by selecting that icon. The hand lets you pan back and forth, and you can also use H to do that on the keyboard. Zoom is pretty much what you'd expect, but the wheel also zooms in, and it zooms in around wherever the cursor is. So if you want to move things a little bit more, you can do that, and it will try to converge towards your cursor. There's a nice little button here that will basically center everything, and up here we've got different views, automatic views that you can put into. Looking down from the top, she's flat. From the side, other side. Yeah, but she's only flat from the top, oddly enough. So, next one, draw. And again, usually use the icons, but you can use the top level ones. Lines are freehands, arcs, 2-point arcs. Pi arcs are basically arcs that give you a plane. A plane.
Fill in.
Yeah,
Fill in.
so it gives you a surface to play with. Shapes, you have rectangles, circles, and polygons. The different tools are basically words for all the things that are up and down the side. Windows, probably won't be using any of that. Plugins, this is one I plugged in, where you can add a lot of different, like staircases. There's a plugin that automatically does staircases if you want to. And window, let's see, extension warehouse. We'll take you to a place that, any second now, we'll have all the different things that you can plug in. There we go. So, and the very first one at the top is the STL plugin, because that is the most popular one. And the second one down is the other one I installed, which gives you a lot of different tools. So feel free to play around with that. So we're going to start off by, let me get a little space here, drawing a circle. Now, if you notice, there's the 3 axes here. I'm going to get rid of that. There's a blue one, a green one, and a red one. So it's basically X, Y, and Z, but they refer to them by colors, so you don't have to remember which way you're looking at things. I'm going to delete the woman here real quick, because that just gets in the way when you select all. And when you, so I'm going to use the circle tool over here, and it assumes, because I'm looking at it this way, that I want to do a flat circle. If I want to do a circle, and let me do a circle first. It starts in the center and then it goes around. Down at the bottom here, I don't know if this will work right away. No, it won't. Okay. When you didn't do exactly what you wanted to do, Control Z always works. Undo. It's also up here, Edit, Undo. So you can undo it and as many times as you want to get back as far as you want to in the list of things you want to do. Control Y is the inverse. It will redo the last thing you undid. So let's draw a circle again. Start it here, bring it down. As I'm holding it, I want to go 5 and make it 5 in diameter. Yeah, 5 in diameter. Yeah. Hopefully that worked. The way you can find out is to go to the little tape measure tool, and it tells you an endpoint, brings it over here, and it's not 5, it's 2.24. So the other way to make it a different size is to go back to select. You want to select the circle. So you have a surface and you've got the blue circle. So both of them light up. I don't know if you can see the cross hatching there when I click on that, but it goes that way. But I want the circle. And then I can left click and go Entity Info. No, yeah, so it's not selected yet. I lost it there. Entity Info. There, it's a circle. And I can tell it what the radius is going to be. I can make it 5. And now it's 5 meters in diameter. That looks a little too big, so let's go to 3. Yeah, that's a little bit better. And then escape will get me out of there. So I want to move it now because it's in an awkward place. So the move tool is the one with all the arrows on it. And it will, and let's put that back there. So I want to move it along the green axis. So the green axis is, I wrote this down so I wouldn't forget. No, I didn't. Okay. So I don't remember which axis is which. So I can go to File, where was it? View, it's Window, Instructor. And that brings up this, which tells me the Move tool. So it tells me what I can do with the Move tool. And down here, it's got up arrow, left arrow, right arrow is to lock the line. So up is blue, left is green, right is red. So I want to go along the green axis. So I use the left arrow, and then when I move it, it will move along the green axis. Now we see a line there, and when the line is green, then I'm still parallel to that. So I move around a little bit more. I want to move over here. So red was the right arrow, I think. Yeah, and it moves. And so things change color. It really tries to guess where you are and what you want to do. I added a guideline there by accident. The eraser button will basically delete things. And you end up going back to select a lot. So the space bar brings you to select always. So whatever you're in, sometimes you forget and it'll keep on doing that. So hit the space bar a lot. So we want to move this again. So I can go down to here and it will put it in the center of things. What I want to do is make a dome. So I want to put a line in. So I'm going to use the line tool. And one of the things you do a lot in SketchUp is touch base on things so it can figure out what you want to do. So I touched the two sides and it turned green, so there was the diameter of the circle. Now it knows I'm looking for the center. So I hit the center and I bring up, and it's blue because blue is the axis, so that's being perpendicular now to it. And see, now I've got another line, so I hit select and it goes away. So I use that because I want to build another circle, or half a circle actually, perpendicular to this. And then I'm going to rotate around that circle to let you know what I'm doing. So I'll go to the pie chart, and this is where it's going to get a little tricky. So now it still wants to lay it flat. So I don't want to do that. So I'm going to use my middle button and try to bring it up to here. So, and it's going to give me a hard time. Okay, let's try it over here. So green. There we go. So endpoint at the end of the line, bring it over parallel to this, and I want to make this 2.8 radius, hit that, and then I'm done. Okay, and then I swing it up and around, and it actually lets me know when I've got a half circle. It will tell me I've got a quarter circle, and it will tell me I've got a half circle. So I want to say, click on it when I've got a half circle, and there it is. I've got this. Now, one of the interesting things that SketchUp can do is now I can rotate that. It's a follow me tool. So, and I'm going to bring up the instructor again to figure out which order you choose the two things you want to do. But I want to rotate the half circle around and follow the circle on the flat plane. So click on Entity or pre-select it. So that's the Move tool. That's not the one I want. I want the Follow Me tool. So you want to choose the path first, is what it's saying right here. So I choose the path, which is actually the circle. Well, let's try that. And then I want to choose this, and then it swings it around. Okay, then it's done. I've got a circle, or a dome. And I'm going to swing around to the bottom, and it's still got it's still there. So I can go to the erase tool and erase that. And everything becomes sort of independent after you draw things. If there's an extension of your line that goes past where you want it to be, it will let you deselect that accurately. It guesses a lot about what you want it to do. Then I'm going to delete the original outside circle, like that. Now, one of the things you want to be able to do when you're designing something that's going to be printed, it's got to be closed all the way around. I delete the bottom, and it guesses that I wanted the bottom. So let's see, or maybe it doesn't have, oh, I got how to do that. Up here we go to View. There's a selection called Hidden Geometry. So right now it is not closed. It is just a shell of things. And you can tell exactly what the resolution of the dome is, or of the circle. There's no such thing as a true circle when you're drawing in SketchUp, so there's just polygons with lots and lots of sides. And you can choose how many sides they're going to be. This is the default. So back to select before I erase something I don't want to erase, but I can go down to the bottom here, and I use the line one, and I touch here, and I touch here, and it closes off the bottom. It knows I want to do that. or it really just wants it, and I can then delete the line, and it's a closed thing. So that's the first part of it. If you want to build something with a wall, it depends on if you want to model the outside of your Mars complex, or you want to pick a single room and then design all the inside of the room. There's two different approaches you take. Right now we're going to be looking at drawing a complex, so we'll just have to worry about the outsides of things. When you design a room, you have to worry about walls and thicknesses and floors and ceilings and windows and all those kinds of things. So it's a little more detailed, but it does that fairly well because it was originally designed to do houses. So the next thing we're going to do is try to do something like Candy did, which is put an entrance on our igloo. So to do that, I'm going to show another tool, which is called the Push Me Pull You tool. So where do I want to put this? I want to, yeah. Okay, I'm going to draw a couple lines that I know where they are. Otherwise, it has a tendency to put things above or below the horizon or wherever you want to put things. So, and it's a little hard because the screen is smaller than I'm used to. But when it goes, you end up moving things around a lot. And it goes a little easier once you use it a lot. So I've been playing with it a lot for the last few days. So there's a line I'm drawing, and it's green, so I want it to be parallel to that. And I want to select and grab the tool again, and then do it from the other side. I want to do it from the green. So, and then slide along here. Okay. And then select. Now I should be able to draw from here, the intersection of these 2 points. So I'm going to go back to this, and it's better at that. So it's got the center there, and then I can go like that and do half a circle. And this is going to be one of the cooler parts of the way Google SketchUp works. It's called the Push Me Pull You tool. That's up here, which is basically a little flat plate with an arrow coming out of it. So you can grab this and you can just pull it. And you can make it as long or short, and then you can grab it again and do that. You can draw something else on it. Let's do that real quick. Back to here. It knows pretty much when I want to do that. Grab another one like this. And then I can do the Push Me Pull You here. I can grab that and I can pull it through and make it hollow. So now it's hollow all the way through. So it does things like that really, really fast. So it's really good for doing like a floor plan, and then you pull the sides in, and then there's another thing that it can do, which I'm just going to show real quick here. Just going to draw a square. The other tool is that scale. That's not the one I want. I want the offset. We can grab this, and it will draw. Just pull in from all 4 sides, and then you can do that. And let's see if I can get in here. H for hand. Roll it back down again, and let's see if this works here. Yeah, there we go. So go back to the eraser, and it's not working.
You select it.
I need to select it first. Okay, so I can select, there we go. And then actually, sometimes the eraser doesn't do what you want it to do, but you can select it and then go delete. Now if I do Push Me Pull You, or push, yeah, follow, yeah, I can lift this up and I can do that. And now I've got a room with walls. Very thick walls, but that's how that works. If you want to grab everything, go back to select, and you put a square around it and go like that, and now selects the entire thing. It knows that you want the front and the back. And the reason I did this separate from the igloo is because once it's touching the igloo, it's really hard for it to not pick part of the igloo, not pick part of the dome. But once I've got it all selected, then I can go back to move. And I want to move on the green, which go back to window instructor to remember which color is which. And I want to go to move. Green is left, right is red. Okay. So I can close this so I can see what I'm doing. Green is left, right is red. So right, I want to move it right, and then I want to move it this way. And I want to move it into the dome. And there we go. And then it is smart enough, and then I've got to hit stop moving. There appears to be some extra lines that got carried along with it, but there they're gone. And there's the other one that's gone. So we have got a little igloo. So we can connect that now to the big square thing. Move again. So I want to move it that way, and then I want to move it this way. Then I want to move it that way again. And then I want to move it this way. Okay, and then I can zoom in again, grab this, and then slide it into there. And now they're connected. So connecting buildings is fairly straightforward. Those are most of the tools. There's another one for rotating. Let's go back to space. This is kind of nice, bringing everything into screen. So I want to select everything. And I can rotate. And it will basically rotate around the space I want. So then, there we go. And down at the bottom you can, I just lost it, you can put the angle in there while you're moving things around, and if you want to get very precise. But it's very good at the 0, 90, 180, 270, 360 stuff. So those are the basics of doing this. So if I want to make this all one piece, I can go to Edit, Make Component, and you can give it a name if you want. And now it's all one thing, and you can grab the whole thing separately. So if I want to select it now, it's just all one thing. And I can copy it, edit, copy, edit, paste, and I can bring it in and put it wherever I want. And you can have two of them. So, and then you can rotate them at different angles and things like that. If I want to make a change to one of the pieces in there, I go back to Edit, and I go to, well, let's stop moving first. Okay, space. Click, Edit. Okay, it's not going to show up there, so it's going to show up here. Explode. So I right-clicked. Explode. Now it's back to pieces again. So that's very useful for moving big chunks of things around, for having multiple parts of it. And then you can actually do things like this. I can grab one little piece of it, do the push me pull, and bring out different pieces of it. So I can put antennas on it or things like that, or little widgets if I want to add some decoration to them. And then you can connect them. So it's very good about guessing where things are. And now it puts if it's got all four pieces, it now makes a plane. So if I want to connect them this way, I didn't connect to that one, so Control Z, grab one corner, grab that corner. Now it's filled in that plane. So if I've got four corners, it is now, and I do go back and do the back side of it, and now I've got a solid that I can play with. So you can make fairly arbitrary shapes. And now I can then push and pull and resize those kinds of things as well. Scaling is the other thing you can do. So I can take this and let's move back to, so I can see everything. Changing the shape and size of something is this one over here. It's called Scale. And it gives you lots of things to hold on to. So I can make it very oblong-y. I can just move, that's pretty much the same thing. If I grab one of the corners, I can scale everything up all together. Or I can make it longer. Or I can make it taller. So these are kind of cool when you're trying to rearrange things. So some fairly simple things, and once you figure out if it doesn't give you the right point of view, you basically have to swing everything around until it's the right point of view. Always guess that you're trying to draw like this. okay? Or it's going to guess that you're going to draw like this, one or the other. So sometimes you have to force it into a little awkward point of view in order to get it to move things and rotate things the way you want to. But after you do it a number of times, it, like anything else, becomes, you stop worrying about it. Just like playing a video game. You stop thinking about the keys and you just start doing things.
Have a couple of questions about
Sure.
SketchUp.
Uh-huh.
Is your printer only compatible with SketchUp or other programs like Unicraft and AutoCAD as well?
Any 3D modeling program will output the right format file for you to build something. There's a few things you have to be careful of when you're designing things to be printed. One, it's got to be closed on all, underneath as well as on top. Having a hole through it like this is fine, but it's got to be, the technical mathematical word is a manifold. So basically, if you pour water into it, nothing will leak out. There's no holes for it to leak out of. The other thing you kind of have to be careful of when you're doing 3D printing, a lot of the newer printers don't worry about it as much, is cantilevers. If you've got something that's tall and you've got something that sticks out over here, and if you think about it drawing, there's nothing underneath it, so it will be printing into space. And if you haven't configured your printer properly, you'll just end up with lots of gloopy things underneath until you're finished. A lot of the printers will build in support structures for those things that are very lightweight and can be snapped off. But once you get a 3D model, there's 2 or 3 other things that you have to do in order to have a 3D print. So you first need an STL file, which is why I talked about the plugin, so I can export this as STL. And it gives me some choices about what I want this to be in, and what format. And I export that, and then I'll say, yeah, it'll go untitled, and it will save. And then we'll save that now in a format that I can print. Like I said, again, Blender and any 3D modeling program that you use will be able to do this, or there'll be a way to get whatever it does into STL. So there's a number of conversion programs out there. So Google is your friend. Take whatever file name it outputs, and then STL and Google conversion, and you'll find a program that does that. Every once in a while, you may have to go through 2 or 3 steps to get there, but it's good.
Another question?
Another question.
Can I send the house design I did to SketchUp?
Yes, SketchUp is very good about, where was that? That's the 3D warehouse. 3D warehouse is get models, or share components. So you can send part of your, so I'm just going to go to get models because I'm not really going to share this one. But, and it brings up a window, and I have to agree to the terms of use and make that full screen. And these are things that people have modeled in SketchUp that you can download and play with and use yourself. It's very big on sharing. It's going to take a while to load, but there it goes. You can type in Mars if you want to get some ideas about what things people have done. But a lot of monuments and landmarks and things have been built for Google Earth. So it's kind of like building things in Minecraft. You do that too. People will duplicate all kinds of things. And SketchUp has the same sort of thing going on. CreatorSpace just did a thing on Minecraft, so that was fun. So that's sort of fresh in my mind. There's some Mars landscaping things you can bring in if you want to build your model on top of something. The Mars Direct Habitation module is something that they've used for the last few years at NASA. They go out to Meteor Crater every year and pretend to be on the moon. And that was one of the experiments they were doing. There are vehicles here. More vehicles. There's some things that you could not print, but there's a Mars base right there that someone did. So it gives you an idea for different ways you can do these kinds of things. And up here you can download that. So sharing is the same thing as if you upload it, and then you have to give it some information and who you are. I don't know what it asks you for, but it should be pretty straightforward.
Okay, we can ask one more at this point. If we made a geodesic dome with a 3D printer, can it keep the oxygen?
if it depends, well, depends on what it's made out of and how it's put together in real life. As far as a model, it should be watertight, yeah. In fact, yeah. There's, not all geodesic domes have surfaces. The ones in the playground don't, for instance. But they're used for radar domes quite often. That was one of the very first commercial uses for geodesic domes, and they support a lot of weight for the surface area and for the weight of the materials. So they're very quite robust that way. Sure, I can do more. Yeah.
Does NASA use REP or RAP printers? REP, RAP printers.
RepRap printers. RepRap printers were the first open source 3D printer. It was designed originally to develop a printer that could print out another printer. So it's self-replicating, rapidly replicating, RepRap. There are, well, a lot of the printers are based on the initial designs, initial concepts of those kinds of things. I'm sure there is a RepRap printer somewhere around the site, the different sites. JSC I know has, or Johnson Space Center has, several MakerBot replicators. Yes, the replicator. As well as, actually, a few years ago, we actually built a Thing-O-Matic I spent like a week building that for Innovation Day. But there's a group at NASA who's working on that, or is advocating those kinds of technologies. There's some professional, expensive powder printers that can print things out of nylon, for instance, which is kind of a difficult material to work with for a number of reasons. But that's probably not where they would fly. But I think, actually, no, I think there was a RepRap type of model that was manifested for space stations. So there may be one up there right now. So.
And this may fit into what you were just talking about. How much time does the printer take to print one spacecraft piece?
Hours, okay. For a real life-size piece, these little pieces here, on my printer, this would take about 30 or 40 minutes. It's relatively slow, and that's with the plastic. And again, I have an older printer, and the newer ones are faster, but depending on the resolution, this is printing out at about 1/3 of a millimeter per layer. You can get down to 1/10 of a millimeter per layer, or less, actually, for very high resolution. And the finer the resolution, the longer it's going to take. So it's not fast. It's not like hitting print and then going and picking it up from the printer bin. It's more like hitting print and coming back a few hours later. And a lot of the RepRap type of models do not run automatically. They kind of have to be babysat. So that's why the actual MakerBot is actually fairly robust as far as being able to let it go and work on its own. We went to a convention a few months back with the library, and they ran it. I ran mine all weekend long, and they ran theirs all weekend long, and we only had to, like, every once in a while the filament got tangled, so they were fairly robust that way. But hours, possibly days, depending on how complex it is and how fast your printer is.
Can you use other shapes, or is dome the best?
Dome is just what you see a lot of on lunar bases and pictures and artist conceptions of kinds of things. Again, they're sort of self-supporting. You can use any shape you want. I think this is limited by your own imagination. Try to think about the physicality of trying to build this in a vacuum with spacesuits. That's one of the problems with living very, very far away from any store or construction company or parts, or Home Depot or Lowe's or anything like that, Radio Shack. So like the one we're looking at right now is very square and very flat and looks like a regular building.
Maybe one last one. What's the average price for a home printer, and what brand do you know?
Okay, our group has looked at this a lot. The very cheapest one we've seen that looks fairly decent is called a PrinterBot, and it's about $350 on Amazon, and it's wooden, and it prints, I think it still prints about a 3x3x3 cube, about the size of a cupcake, as we used to say. The metal version of that, which is a little more solid and fairly robust, a friend of mine has one of those and has been printing a lot, using it a lot. It was about $600. Off the shelf, maker-bot replicator that you can just take out of the box, plug it in, and it will print something almost in 20 minutes is about $2,000. And you can build one yourself for about, out of parts, if you want to source it yourself, for about $500, $600.
All right, that's all the time we have for today. Thank you very much, Candy and David, for coming out and giving us a great talk about 3D printing and helping these guys out. So thank you very much for joining us today.
You're welcome.
Thank you for the opportunity.